This is clearing up cloud confusion. I wanted to call it Cloud for Dummies, but they wouldn't let me, and I was going to call it Cloud for Clueless, and they said nobody would show up. So clearing cloud confusion is for that. And basically the goal is to help orient the layperson to what cloud really means. So I'm going to go into a little bit about what the background of cloud, not a whole lot. I'm going to give you the formal definition of cloud, and if your eyes glaze over, that's quite all right, because I'll skip right past that and go right into what cloud really means for you, and what then cloud means for me in the government. I'm the Chief Information Officer for Department of Energy, Richland Operations, and Office of River Protection, which means I set the strategic direction for the IT on the Hanford site and the cleanup, and also provide oversight with a lot of help from my friends. Where did the cloud come from? Well, in a nutshell, people got tired of drawing that. And you started seeing these creep into network diagrams. All the techies in the room are going to giggle, but you start to see, things here, and we've got systems over there, and then it touches the cloud of systems over here, and it all kind of boils down to the old here be dragons. The cloud was anything that you can put on a diagram that said magic happens over here. We don't really know what's going on. We're not going to diagram it. We're not going to spend a lot of time and energy into it. But out there, somewhere in that nebulous realm, magic happens. Formally, NIST has defined the cloud being composed of basically three things. 5 essential characteristics, and these are really the key biggies right here. If you don't have these, you're not technically a cloud. On-demand self-service. You can go out and when you want it, it's there. Push a button, you've got it. Broad network access. You can get to this cloud from anywhere. Resource pooling. I'll skip over that one, but basically it's the flexibility and the ability to get access to a lot of things in a distributed fashion. Rapid elasticity is if you need more, you can get more instantaneously. If you need less, you don't have to pay for a lot more. You suddenly have less. And then measured service is a way that they can give you discrete chunks of that and either bill you for it if it's a paid cloud service or track it in usage base, and you see all the statistics on how Facebook has got 700,000 people added a day. Those are how they measure these services. I'm going to breeze through this kind of quick. The 3 service models of cloud is another piece of the definition that NIST gives. Software as a service, being able to give you, let's say, Microsoft Word. Anybody in here use Gmail? Mail, software as a service. Platform as a service, if you could actually rent like a Windows box online, and then infrastructure as a service where if you wanted to go in and do whatever you wanted, you just needed a bunch of servers and you were going to put something on them. That's infrastructure as a service. You can combine those in various ways to get things like desktop as a service. And then there's 4 deployment models. You note my super cool graphic skills over here at the deployment models. And that's basically just saying you can have a cloud that's out there that's publicly available like Google. You could have your own internal cloud if you spend enough money to do so that nobody else can touch. That's a private cloud. And then if you start combining the two, you get things like the community cloud, which is a cloud that a bunch of similar organizations share, or hybrid clouds, which is an actual hybrid combination of multiple clouds. And that's it. That's a formal definition. And now you can forget it. Because what the cloud really means, and I'm going to tell you this, and then the IT people will revoke my IT card. This is what the cloud really means. Anywhere that you can say, somewhere beyond the boundary of my computer, outside of my computer, my phone, my laptop, my iPad, somewhere out there, magic happens. Something happens. What does it really mean for you? There are 2 things you can do in the cloud. And I'm kind of, boiling this down. But basically, you've got processing and you've got storage. And this is really kind of a misnomer, but you can, on the gradient, give those a distributed and flexible approach. So from a processing perspective, let's say that you were the New York Times and you had thousands and thousands and thousands of back issues that you had scanned into images, and now somebody came to you, your boss, and said, these images are great, but they're not PDF searchable. I want you to turn all these things into searchable documents. Make it so. And you tell them that's terabytes worth of information. That's more information that would fit in this room. It's going to take all the computers we have here. If I took every single last computer at the New York Times, it's going to take all of those computers the next decade to process that. Or you go to the cloud, and you turn that into a job, and you upload it into this giant computer grid, and a whole bunch of computers somewhere else that you're renting by the hour crunch through that in 7 hours. That's your distributed processing. Flexible processing. It's there when you need it, on demand, right then. You upload a video into YouTube, what happens? It actually converts that into a certain format behind the scenes. You can upload all kinds of different videos from your cell phones and your computer and all kinds of things, and behind the scenes, right then and there, it's being converted on the fly. It's your flexible processing. It can do just about whatever you want, whenever you want, and however you want. From a storage perspective, what does it mean for you? Well, it means that you can back up your data now cheaply. I mean, you can buy cheap terabyte-sized hard drives down at Costco. I saw they had a 3 terabyte one there the other day when I was in there. That was great. And if my house burnt down, it doesn't matter that I've got, my hard drive could fail at home, and that would be great. I've got a backup, and that backup is sitting under my desk right next to my main hard drive. If my house burnt down or somebody broke in and stole all my computer stuff, every last baby picture would be gone. I've got the cloud. I can start backing these things up out to any number of different services out there. And some of them are pretty easy to use. Some of them looks just like another drive on my system. I have access to my music and my videos that are sitting at home while I'm on the road. All my email, it's in Gmail. I can access that from anywhere. So the storage is the other half of the cloud computing. I thought I'd throw a couple of these up here. These are just a couple. There's tons. And remember, I'm not going with the NIST standard. So some of these things, a lot of the IT techie folks in the room would say, that's not the cloud. Well, according to the definition I gave, cloud is anything that you don't have to worry about. These are. YouTube. Giant server farms out there crunching video. Peter Layden just gave us some statistics during lunch that every minute, 24 hours of video is being uploaded to YouTube, and they're crunching all of that in the cloud. Flickr, it's a giant photo repository, and they're doing all kinds of great things, tagging and image recognition and indexing and database stuff. And Facebook, and soon, if not already, Facebook will start doing image recognition in the cloud. Giant server farms all over the place crunching through information out there somewhere. A lot of people are using Facebook as their photo repository now. They're not using it just to connect with their friends or chat or do these kinds of things. They're actually using it to store their pictures in Facebook's storage. Dropbox is another storage provider. Animoto lets you take a bunch of pictures and turn them instantly into this cool music video. They have a bunch of smart software behind the scenes that you just pick the pictures, you pick the music, you pick a template, and out the end it spits a music video. Google Docs, Google Apps, spreadsheets. Last time I rebuilt my system at home, I haven't even put Microsoft Office back on there. Doing all my processing in the cloud now. iTunes, 65,000 apps, billion downloads of apps. All of that's on a server somewhere, and you don't have to worry about it. You click a button, it's there. Instantaneous. You click a button on your phone or on your iPad, it's there. It's delivered. Microsoft Office Live, you can now use the full Office suite in the cloud. Skype, I'm sure everybody knows what Skype's about. I'll skip through the rest of those, but the point is made that you guys are using cloud services every single day. And the ability to do things easily and beyond the processing and storage capabilities of your current systems at home is incredible. Very soon, you're not going to have anything at home but a phone or an iPad because you won't need to. You won't need to have a desktop. You won't need to have a network even necessarily. You'll have a wireless router hooked into your internet service provider, and you'll have an iPad or a phone or some kind of smart device. What does it mean for me and business in general? Well, same kind of things it means for you. Efficiency, cost, disaster recovery, continuity of operations. If I can use the cloud more cheaply than I could building the infrastructure that I need myself and do it in a secure fashion, why wouldn't I do it? If I can do it in a way that the users are happy with, if I can convince my users to use Gmail instead of Outlook, I might be ahead of the game. If I have a whole bunch of information that I want to make sure doesn't get destroyed in an earthquake or a tornado, as the case may be? Well, you're supposed to do what's called offsite storage. In a lot of places, they burn all of their information to a tape every single night, which is an arduous process, and then they put it in a truck and they drive it down to a vault somewhere else. Or they could use the cloud. All that stuff synchronizes automatically. Just set up a job at night, every single night, that just pumps information out there in a distributed fashion. From a scalability perspective, if I get, let's say ARA, the economic stimulus, and I get 3,000 new workers on the Hanford site, well, I'm going to have a lot of infrastructure to keep up with those 3,000 people. Now, luckily, we have a lot of cloud features built into our infrastructure where we were able to scale very efficiently. Those are the kinds of things companies look at. If you have an email system that you host yourself and all of a sudden you get 3,000 new people, if you don't have it planned for, you're going to glut the system. If you're using the cloud, it's scalable, it's on demand. I need more servers, there we go, more servers by the hour. A lot of these places, the high availability websites, you'll see a website that goes viral and it gets really popular, it gets millions and millions of hits and the website goes down. Well, a lot of them now can use the cloud and they host their websites in these high availability distributed data centers where they get swamped with requests and they just order more servers automatically. They don't even have to touch a button. It's all just programmed in. Their web server knows that they're getting slammed with users, they're getting more popular, and behind the scenes it just asks for more and more and more. And when all those users leave and stop using the system, it just starts spooling those down and giving them back to the cloud. And you only get charged for what you use. That's that measured or metered. And that is really it. I know I went through it really quick, but I wanted to leave a lot of time for questions. Sir, Tom.
Can you comment on the challenges with data recovery and archiving and information recovery right now with the cloud?
So he asked, what are the challenges with information recovery and archiving with the cloud? Is that correct? Basically, the big challenge, and it's not just me, and it's not just the business, it's really something you should be concerned about, is security. There is, as one of the other gentlemen in the room pointed out, there is no undo button. If you publish information to the internet, kiss it goodbye. It is now out there forever. If you post a picture on Facebook that you did not mean to post, I'm sorry. Start doing your damage recovery. So one of the challenges that we have is making sure that we're using encryption, we're using security, we give access to only the right number of people. One of the things that I'm not getting into a whole lot of detail on, but we have certain things we have to follow for the government. One of those is FISMA, which means you have to jump through a whole bunch of hoops just to use machines. We still have to address those challenges. From a government perspective, a lot of those haven't been met. There are very, very few FISMA certified cloud providers. From a business perspective, you've got a lot more flexibility. It still is really important to make sure that you're doing it in a secure fashion. And you don't give the keys to the kingdom to everybody. From a personal perspective, just be careful what you put out there. Use the secure HTTPS when possible instead of the normal unsecure HTTP. And if you can get some of your places like banks and things let you get tokens, or you can use two-factor authentication, I recommend getting those if you can. Sir?
Do you believe that the cloud system could be used for things such as the Human Genome Project, astrophysics calculations for figuring out the velocity you have to travel to not get crushed by a black hole?
Absolutely. Distributed computing is already being used in the cloud. Things like and it's been since actually before the cloud term was even coined, SETI at home, where you have volumes of radio telescope information being processed in a distributed fashion on people's home computers. The Human Genome Project, just even if you factor out computing and all the number crunching that has to happen from mapping the genomes or watching proteins fold, All that aside, just the ability to use the cloud as a collaborative space to share information and to communicate with other researchers is a key factor in things like the Human Genome Project.
So taking off a little bit on his question, what's to keep my son from doing some great internet Mersenne Prime search and I wake up the next morning and have a huge bill for all the resources he's consumed?
Two answers to that question. One I won't give, and the other one would be good and bad data caps. A lot of internet providers are now capping your internet usage at a certain rate. If they see that you're starting to skyrocket, they'll usually suspect that you're downloading movies or music or something illegally, and they'll start capping you at a certain level. So that would help. And the other thing is that not too many providers or not too many normal internet service providers in the domestic U.S. meter usage like that. They usually give you like a 12 megabit kind of package, and you can download as much as you want, and they usually have a terms of service that says reasonable use somewhere in the fine print. But you can download as much as you want within a certain speed, and they're not going to blink. But every single one of them reserves the right to make sure that you're reasonably using it and throttle you down if they think you're not being reasonable. Tim?
I know it's a popular topic recently. I mean, April was a really bad month for data breaches and security of the cloud. I mean, Amazon's cloud compute services and Elastic, their EC2 services on the East Coast availability zones went down on human error. I mean, I like the believe incompetence rather than maliciousness whenever it's possible, but human error brought them down. Sony's data breach of now over 100 million usernames, is the cloud something that we can trust at this point for anything of value, including my name and my address and my personal information that I don't necessarily want shared?
Trust but verify. If you take reasonable precautions, now the Sony thing is that's a good and that's a timely example. You had, as a user, no way of knowing what Sony did with your information. I guarantee you that nobody, none of the millions or thousands of people who played on the Sony PlayStation Network knew that their passwords were hashed. You have no idea how your password is stored and what's being handled with it. Some of that will have to become more transparent as we start running into these kinds of things on a more and more frequent basis. Companies will have to start basically security through obscurity is not security. And I knew you'd ask me a security question. Security through obscurity is not security. So hiding the way you do business. Recently, one of my last examples, Dropbox, the big storage company. You can get Dropbox app on your iPhone, on your Android platform. You can use it on your computer. It's a great way to share files. Some smart guy figured out their mechanism behind the scenes and figured out that you could anonymously share files without actually having to have a copy of the file yourself. You just had to figure out what the fingerprint of that file looked like and give it to your friend, and he could put that fingerprint in and instantly have the file. Dropbox was not very happy about that because it turned them into a giant peer-to-peer file sharing service a la Napster. But they had hidden the way they did things, and if they had been upfront about it and a little bit more public and said, hey, this is what you do with your data, we protect it reasonably, we encrypt it, et cetera, it would be different. If you take the precautions to encrypt your information, be a little bit more secure, be a little bit wary of what you read the privacy notices. No, nobody reads the terms of service or the end user agreements, but read the privacy, because some of them, I'm not kidding you, said right in their privacy statement, we will sell your information. And everybody thinks that just because they have a privacy statement on their website, they must be private. No. They have a privacy statement that so they can point back to it and said, well, we said we could sell your information anytime we want. You signed up for it, you poked the button, we'll sell it. Read the privacy agreements.
So Ben, along those lines, what about viruses? Do you see the shift of scrubbing the viruses moving over to the company that's in charge of the cloud app out there? Or because it's now not just going to hit one individual that downloads the wrong email, it could potentially just the virus could run rampant around the entire cloud itself.
We're seeing some of that already. As from a malware perspective, we're actually safer in a lot of regards than we have been in the past. And because using those cloud-based services where all of the computing and processing and all of the things happen in the cloud beyond the realms of your computer, the risk goes to the cloud. If you're using a desktop as a service and you're renting a Windows box from somewhere and all you get is a pretty picture of a Windows desktop that you're using, and you go out to a website and it does a pop-up and you don't notice it and you click on it and you get some malware on your box, well, it's not really your box. You push a button, it gets destroyed, it gets recreated, all your information's safe. So there are some things about the cloud that really make it a lot nicer from a malware perspective. On the flip side, and what we're seeing a lot of, and it's not really, I don't know, it's kind of a concern and it's not really a concern, are those social network, they call them worms, but it's not really a worm, it's just something, it's somebody that convinces you to give them permission to use your account. Hey, we've got this great new Facebook toy. Let us access your Facebook account and you can play with this Facebook toy. And then, of course, it spams all of your friends and all their friends and all their friends, and pretty soon it's spreading like wildfire throughout the Facebook. But what? So what? It's limited to Facebook. It's got access to your Facebook account. You go in and you change your password, and the damage is done. There haven't been any yet malware attacks that I know of that have been able to propagate through the cloud infrastructure behind the scenes, like where, just say Amazon and their giant cloud infrastructure that everybody can rent. I haven't heard of any kind of malware that's basically taken over Amazon's cloud infrastructure and wiped out all their customers. There are a lot of good safeguards in place to prevent that. Not saying it couldn't happen, we just haven't run into it yet. Sir?
There were companies and services, say, in the 90s that were big players that are gone now. So if you go with a cloud provider now and you're warehousing your data there and you're doing your services, down the road you have no guarantee that they're going to be there, even though they're one of the biggest players now. So how do you safeguard yourself if you've put all the effort into moving your stuff to the cloud, that cloud's not going to disappear?
That is an excellent and a timely question. A lot of folks are taking the cloud of clouds approach, and that's where basically, some people, for instance, will upload their photos to Facebook and to Flickr. Some people put all of their social connections in a couple of different places. Some people download all of their email from Gmail. So doing that to a certain extent or beyond a certain extent defeats the purpose of the cloud. You're using the cloud because it's easier. You don't want to have to back up your data on your own system. You don't want to have to download it. But data portability is a huge issue. Delicious, social network, social bookmarking site, started up many years ago. And people could go out and bookmark things and give people access to the bookmarks and index them, tag them. It was a great way to store your bookmarks. In fact, that's how I store my bookmarks, because every time I got a new computer, I'd always forget to transfer my bookmarks over, and then I'd lose a whole bunch. Well, Delicious was bought by Yahoo, and then Yahoo last year, or earlier this year, said, you know what, we're going to kill Delicious. All of you people who have all of those bookmarks in Delicious, everybody freaked out. Everybody went out. Luckily, Delicious provides you the ability, the data portability to go out and download your information. And everybody did. Everybody said, oh no, Delicious is going to go away. And turns out it was purchased by founders of somebody else. And to touch on another question earlier, there was a new privacy policy that you had to accept when you switched over. When you logged into Delicious the next time after it had been purchased, they said, we're under new ownership, new rules, please sign this privacy policy. And it's a little different than the old one. And a lot of people just click through it. Facebook used to provide a way to do data portability. Twitter, as far as I know, does not. Flickr, the photo sharing site, if you are a premium member, which you would have to be if you're dumping a lot of images and storing them out there and using it like you would want to use it. Unfortunately, the way Flickr's set up, if you let your pro account lapse, they don't give you access to anything. So you'll have to take a grain of salt. Look at what you're doing, look at the service you're using, and figure out if that's something that you want to take advantage of. What we're seeing creeping into the consumer level is that cloud of clouds again, where there are services out there that are now offering aggregation of other services. I put a file here with you, and I know that you're storing it on Amazon, and you're storing it on Microsoft's cloud. Now, I'm pretty sure Amazon and Microsoft are going to be around for a while, but those kinds of things. Stick with the name brands, look for the cloud of clouds. If they have a data portability, use it, download it, stick it on your hard drive. It's not a bad idea.
I have a question. What about the possibility of thieves using the cloud as a tool to, say, hack into the U.S. and ship 20,000, 8 billion in quarters there to a bunch of different locations, or even the private sector stealing a new design, like say Richard Branson wants this design that SpaceX has, so they use the cloud to steal the SpaceX design and transfer it there and make more money.
Yes, in a probably not quite such a die-hard fashion, but the cloud processing capability has a lot of power. A lot of people are very excited by the fact that I can spin up the equivalent of a supercomputer with a push of a button. For a couple of $100, I can have thousands upon thousands of computers somewhere crunching through somebody else's password list looking for matches. It's being done today. Organized crime is using it today. And I guess I'll get into how much time do I have? I'll get into security a little bit. Anybody heard of a botnet? Awesome. Somebody in this room, at least one of you guys, has a cloud computer at home. And by that I mean you've got a computer that's been infected unknowingly to you by malware and is now part of this giant network, this cloud of computers out there that they call them botnets, and there are zombie networks where basically it's just sitting there nice and quiet until somebody somewhere, and usually it's some mobster in a Eastern European country, says, I'm going to hire this guy, and I want to rent a bunch of computers because I want to send Viagra ads to 10 million people. And so he pays a whole bunch of money, and this guy gives him access to this giant cloud of computers for however long it takes to crunch through 10 million emails. And what it's really doing is sending a command to your infected computer at home and telling it to act like a mail server for a certain period of time. And then it does its business and then quietly goes about letting you do your business. You're sitting there playing World of Warcraft and never knowing behind the scenes that your computer is being used for organized crime. Another really good reason to make sure you've got good malware protection and really you're not using vulnerable browsers. So yes, the cloud processing capabilities, it gives the criminal element or bad actors from an intelligence perspective the ability to much more do everything that I can do. I'm interested in the cloud because it's flexible and it's cheaper and it's scalable and it can do all these great things. So it's the same exact reason why the mob bosses like him too. Sir.
Most of the discussion today has been around, for the cloud, has been consumer applications. You touched upon business and government. You feel with all the legacy applications out there, for example, somebody has an application in COBOL DB2 or whatever, do you see the future of business and government being a hybrid environment? And how soon do you think maybe these legacy applications go away and it's transferred to the cloud?
Hopefully sooner rather than later. I've got a few of those myself I'd like to get rid of. It's a financial question. It boils down to money. It will be, if not already, cheaper to have a virtual legacy server being emulated in the cloud than it is to maintain that virtual server on your physical premises very soon, if not already. So if you have an older flavor of HPUX with something running on it, old COBOL or old Fortran code running out there in a server, chances are you could get a server that could do the exact same thing and get rid of that physical iron in your server room or your data center. But the applications themselves, you're not going to move that unless you convince your users or your application owners to pony up the funds, or you do it yourself, to move them off of it. I would dearly love to get some of my legacy applications that I have off of, get the users who are using them off and free up enough money to be able to get rid of that iron. We're 90 some odd percent virtualized, 97, 98, something like that. So I'd like to get 98, 99 if I could. But it's going to take some time and money, because there are people who love those old COBOL applications. They've got a lot of data in them, and migration is painful. You can actually, from a legacy perspective, you can actually run a Commodore 64 operating system in the cloud now. I think I've got it on my phone, as a matter of fact. Does that help answer your question at all? I mean, the capability exists. It's just not something, it's not easy to do, because it involves a human element. You've got to get the people who are using those applications and who own those applications to participate in what you want to do. And if you're going to that extent, well, you might as well look at actually migrating out of the application rather than migrating the host of the application. Start using something. If you're using a homegrown or an old legacy CRM system, oh, look, there's SugarCube and Salesforce and a bunch of other ones out there in the cloud. They're a lot more bang for the buck depending on how big your enterprise is. Questions? Softballs? Time? What time am I supposed to wrap it up?
Question about network requirements for the cloud. So if you're going to be moving your computing into the cloud, or virtualizing your desktops and all that, not just on premises, but having that actually elsewhere, it's been my experience in a lot of places that the network isn't up to that in terms of its speed or its reliability. What do you see? I mean, do you see that changing soon, or what can be done now to prepare for that?
Advanced protocols. It's a huge problem when you start looking at, and if you're looking at from an enterprise perspective, where I've got hundreds or thousands of users who need access to these services. Email's one thing. Most emails you could figure out a way to do it and use slower pipes, and maybe you'll be okay as long as you don't have those PowerPoint rangers out there sending you 25 meg PowerPoints. You start to get into more like the desktop as a service. You have to look at something other than out-of-the-box thinking. Things like the PC over IP or the new RDP protocols and things like that that are a lot more efficient. We've got some on site that can push high-def video, but we're sitting on a pretty nice network. I start looking at the cloud providers. I have to be very judicious and factor that into my equation. It's not just the return on investment, it's the user experience. User experience is huge. You can't move your stuff to the cloud just because it makes financial sense to do so. I'm sorry. My users would string me up if I moved them to Gmail. They would kill me. I just couldn't do it, because there's certain user experience they expect, even if it's cheaper. And so it's a matter of managing your users' expectations, looking at the technologies that allow you to leverage what bandwidth you have. And bandwidth is getting there. I mean, there are things that you can do these days now that you didn't used to be able to do from an aggregation of bandwidth and multiple carrier perspective that make it a lot more efficient. And some of the newer protocols, like I said, make it a lot more efficient. We're getting there. You'd have to have a pretty small enterprise or not being doing any heavy lifting to be 100% completely cloud right now. I mean, I'm talking from an enterprise perspective. There are a lot of small businesses that might be able to pull it off, but you're talking a couple hundred people. I'm guessing you have a server somewhere in your facility.
From a security perspective, can you build your own cloud inside your facility? We have 630 employees. It'd be nice if we had an intranet type of cloud internally. Is there any advantage to doing that versus traditional servers?
Sure. If you're paranoid like I am, and I'm professionally paranoid, that's a great way to go. There's a lot of companies that do exactly that. They build their own private, that's why NIST has that as part of their deployment model, private cloud. The National Nuclear Security Administration is looking at, they've got private cloud. DOD, DISA, Defense Intelligence Service Agency, something like that. They've got a private cloud that Army and some of the other guys are using, not connected to anything else. It's completely standalone. There are places now that sell a private cloud in a box. You can call up the joint venture between EMC, Cisco, and VMware and tell them what you want, and they'll send you a rack of equipment. You plug it in, the power, you plug it into your network, and you've got one configuration interface for a cloud. Just because you have a private cloud doesn't mean you have to completely firewall off and air gap your network. You can do what you normally do. It's just that your users, let's say that you have one of the labs down at, I think it's Los Alamos, has a platform or infrastructure as a service cloud internal. And they're different. They're a lab, so they have research and development organizations that need a server for something. I want a server because I want to crunch a bunch of numbers on something, and so they want to order up a server. Now they've got an ability, and it's truly cloud that can request it on demand. They push a button on a website, on the intranet website. They push a button. It says, how big? Yay big. How long? Yay long. Thank you very much. What's your billing number? Give them your project code, and there you go. Here's your new server. Thank you very much. When you're done with it, it turns it off. Your project gets billed for it. That's all internal. Now, other users, I'm sure, can still go out and look in Google and surf the web. It's just how they have the enterprise architected. The services, the cloud services they're offering are internal only. Yep. Not any different than the servers that you already have in your network. It's just that they're configured in such a fashion to fit the cloud paradigm. Somebody once told me if there's a technician involved anywhere, it's not cloud. Now, like I said earlier, cloud for you is anything that's outside of the boundaries of your computer or your phone. But from a NIST perspective, yeah, cloud is, I want it, I push a button, it happens automatically, and I don't have to go call up, Jill IT girl to help me out. Again, and that question is kind of similar to your last one. If you have a lot of processing capability and a lot of money to throw at it, you could start doing things like that. You could start brute forcing. We haven't seen a lot of that from a security perspective. What we've seen more of is people taking advantage of botnets and cloud computing to do a distributed denial of service attack on either businesses or nation states. So they'll decide that they don't like the government in some corner of the world, and they will take down that entire government's internet or intranet. That's more along the lines of what we see. But anytime you throw a lot of number crunching power at something, you can do things, crack passwords. And I'm about 6 minutes, is that right? Nope, I'm done. All right. Catch me afterwards. Thanks, everybody.